A conversion of area. So if we're looking at area, we're looking at everything squared. So from linear kilometers to meters, we would multiply by 1,000. Well, now square kilometers to square meters, it's 1,000 squared. From linear meters, like line, to linear centimeters, times 100. But in this case, we're going to times by 100 squared to get the square version of that. So, so if we were to look at 1 square meter as a line has 100 centimeters in it, but 1 meter as a line has 100 centimeters in it, but 1 square meter has 100 times 100 in it. So that's 10,000 centimeters in a square meter. So here we have the formulas for the areas of these different shapes, which we'll employ below. But first we're going to convert. So to convert from square millimeters to square centimeters, I'm going to go back up and look. Square millimeters to square centimeters, I'm going to divide by. So to go from square millimeters to square centimeters, I'm going to divide by 10 squared, which is 100. So in this case, I'm going to have 859 millimeters squared, and it's the unit that's squared, not the number. And all I do is divide that by 10 squared, and that'll give me 8.59 centimeters squared. So that's millimeters to centimeters. Remember that 10 squared is just 100. So in this case, going from meter squared to centimeter squared, I'm going to take my number of 2.37 meters squared, and I'm going to multiply that by 100 squared, which is going to be 10,000. So it's going to be a big difference, but it sort of makes sense if we're going from square meters to all of those square centimeters. That's going to be 23,700 centimeters squared. So once again, I just used that conversion chart that was up the top. If I'm dealing with square units, the same rules apply. From meters to centimeters, it's still 100, but it's 100 squared because there's that many more. Now, find the area of each of the following figures. The area is going to come out in square units. This is a rectangle. Area equals length times width. So it's as simple as, it doesn't matter which one you call length or width in this case. The area is going to be 7 times 3, which is 21. My unit is meters, so I'm going to put square meters. Now I've got a triangle, and so the area of a triangle is equal to 1/2 base times height, or exactly the same thing, base times height over 2. Just depends on which way you like to look at it. I'm going to do the second way, 1/2 of 5 times 11, so 55 over 2, or 1/2 of 55. So the area is going to be equal to 27.5. What do we have? Kilometers, and the unit is squared. When we have a parallelogram, if we go back and look, the area of a parallelogram is like a triangle, but it's not half. So that is simply base times height. We have to have a perpendicular height to get an area here. So base, let's do it right, is 3 times 1.5. So the area here is 4.5. The unit was centimeters, so now we have square centimeters. The area of the following figures, now we're going to use X and Y for this shape. For a rhombus. Yep, it is a rhombus because they have all the same sides. So our rhombus is going to be 1/2 of the diagonal times the diagonal. So you could put all this over 2 times 10 times 9. So half of 90, the area is going to be 45. The unit's millimeters, so I'm going to square the millimeters. Now I've got a trapezium, and trapezium area, and once again, this is on your sheet so you can look, is 1/2 of the sum of the top and the bottom times the height. So filling this all in, 1/2 of 4 plus 6 times the height of 3, and that's 10 times 3. That gives us, it doesn't matter how you want to work it out, but you're going to end up with 10 times 3 on half of that. So our area is going to be 15. The unit is meters, and we square the meters. So we're just applying those formulas. And finally, we have the special circle and sector to deal with. So the area of a circle is pi times the radius squared. So we need a radius. We can't use a diameter for this one. So it's pi times 5.1 squared. And if we use our calculator, our area, I'm going to put about I'm going to use a slightly squiggly line there, 7.1, because we have been asked to round this to 2 decimal places. What's the unit? Centimeters. And because it's area, we square the unit. I can't say that enough. Now, sector is the same thing. The area of a sector is whatever the fraction of, or times, the whole area, pi times the radius squared. So we get the fraction by using our theta number. So we've got this big angle here as 260 over 360 times pi times, what's our radius? 4 pi times the radius squared. So if I want, I can just go straight into my calculator and type 260 ABC 360 times the pi button times, I would put 16 in there right away. You could go through and reduce it if you needed to do it, if you wanted to use your calculator to do it. Pi times 16 is 16 pi, and we're just going to multiply that out. If we wanted an exact answer, we would leave the pi in there, but we want it to 2 decimal places. So that gives us, I'm going to again put a squiggly line, which means it's rounded to 36.30. The unit was meters. The area is in square meters.